Let us now discuss filters. What is meant by a filter? A filter will allow only certain frequency components. So depending on the frequencies that the filter allows, it is divided into various kinds. So we will see what are those different types. Here we are talking about passive filters only. So that means using R, L and C components. Active filters will include electronic components, transistors, right, op-amps. So that's not what we are discussing. We are discussing only the passive filters here. Okay. So the first kind of filter is the low pass filter. What does the low pass filter do? As the name says, it allows only the low frequencies. Allows low frequency components. Okay. So this is going to look like this. There will be a resistor, there will be a capacitor like this. Now the voltage, the input side voltage is applied to the entire branch and the output is taken across the capacitor. What will be this input and output voltages? We are talking about the periodic signals. That is when the frequency comes into picture, right? So here we will take this to be Vi of S, the Laplace functions. Now this resistor is R and this capacitance is C, let us say. Then what will be the transfer function? Transfer function is output by input, and this you can get by the voltage division, right? So V0 is going to be 1 by SC times R plus 1 by SC into Vi of S by Vi of S, right? So Vi of S and Vi of S are going to get cancelled. You are going to be left out with 1 by SC divided by R plus 1 by SC. So what will this be? If you simplify, you are going to get 1 by 1 plus SCR. So here you can see that as S tends to, S is equal to j omega, right? If you take a sine function, then as frequency tends to infinity, that means for high frequencies, then S will tend to infinity. Then what will happen to the transfer function? This will become 0. Okay. You don't have to take an infinite number. Even if you take a very large number, then 1 by very large number will give you a very small number. So the output that you are going to get, it will be very small. Okay. So that's why it is called a low pass filter. When frequency is less, denominator will be less. So this entire quantity, it will become very large. So it will be passing the input towards the, it will reflect on the output side. So if you take a graph of the transfer function as a function of omega, okay. So what is going to happen? For low frequencies, the transfer function will be present, and at high frequencies, it will not pass. Okay. So this is what we call as the ideal characteristics. In a normal practical characteristics, this abrupt change will not be there. It will slowly taper off. Okay. So let me draw the practical as well. So this is the practical filter, and this is the ideal filter. So what is the difference? In ideal filter, after a certain frequency, let us say this is omega cutoff, okay, lower cutoff frequency, let us say. Then what is going to happen? Immediately after this frequencies, the filter will not allow. But that's not going to practically happen. In a practical filter, even after the cutoff frequency, some frequencies will be passed, but the transfer function magnitude will slowly start coming to 0 till it becomes negligible. The next kind of filter is, first we discussed the low pass filter. So now it should be high pass filter. So what will a high pass filter do? It will allow only high frequencies to pass through it. So that means when given an input, then you will get a sizable amount of output. Okay. So what will this circuit look like? Here there is going to be a capacitor here and a resistor here. And the output we are going to take across the resistor. V0 S. So this is R and this is C. In a similar way, you can find out the transfer function here. V naught of S by Vi of S will be equal to, the voltage is taken across R divided by R plus 1 by SC. So what you are going to get? SCR divided by 1 plus SCR. Okay. So you can see that for small frequencies, meaning that we can take S tends to 0, then what will happen to the transfer function? Limit S tends to 0, SCR by 1 plus SCR will give you 0. Okay. For large frequencies, what is going to happen? Here S tends to infinity. Then what will happen to the transfer function? Limit S tends to infinity, you can get in terms of 1 by SC term. So you will take the first expression, R by R plus 1 by SC. Now 1 by SC will become 0 as S tends to infinity. So you are going to be left out with 1. Okay. So if you give Vi of S, then V naught S, you will get the same output, Vi of S, for large frequencies, that is the high pass filter. Now what about the characteristics? The transfer function, when you plot as a function of frequency, then you are going to get, after a particular frequencies, all of the frequencies will be passed. So this we can take as the higher cutoff frequency. Then once again, this is what? This is the ideal case. What will be the practical case? Slowly it will start and then it will go like this. So this is the practical case. The next we have a band pass filter. So as the name goes, this filter will allow only a certain range of frequencies. Allows only certain range of frequencies. So how will you get it? You can take a combination of the low pass filter and the high pass filter. Let us say this represents a low pass filter and here you have a high pass filter. Okay. Now what are the characteristics of each of these filters? So the low pass filter, let us say the characteristics are like this. This omega 1 will be the cutoff frequency, and for the high pass filter, let us say omega 2 is the cutoff frequency. Okay. Now if omega 2 is less than omega 1, then you will get a band pass filter. So you can see here all of the frequencies 0 to infinity frequencies are passed to the low pass filter. Then what will you get the output? You are going to get only from 0 to omega 1. 0 to omega 1 frequencies are only in the output. And these frequencies, when you give to the high pass filter, what will happen? It will only pass the frequencies which are greater than omega 2. So you are going to get omega 2 will be here, only those which are greater than omega 2, but input only we have given only till omega 1. So you are going to get a filter which will pass the frequencies omega 2 to omega 1. Once again, this is the ideal case, right? What will be the practical case? It will start gradually, it will come here and then gradually it will go down. Okay. So the next type of filter we have is the band reject filter. So what does this mean? It will reject certain range of frequencies, just the opposite, right, to the band pass filter. So here slightly different. What will it be? We will use both the low pass filter as well as the high pass filter, but you are going to, instead of the previous connection is called as a cascade connection, right? Here you are going to add it like this. The input is given here as well, here as well. What are you going to get in the low pass filter? This will be from 0 to omega 1. All of the frequencies are given, but this will pass only the low pass frequencies, and the high pass frequency will pass from omega 2 greater, from frequencies greater than omega 2, so that the output you are going to get 0 to omega 1 and again from omega 2 to infinity. Okay. So you are adding both of this. So here I have not given you the actual circuits, I have given you a basic understanding as to how using a low pass filter and a high pass filter it is possible to obtain a band pass and a band reject filter. Okay. But this addition here, it is more easily done with the op-amp circuits, summing circuits. Okay.